Marcy Louder. I'm a rising senior in textile engineering. This project was definitely something different, something I've never heard of, and it was something that I felt I could apply my knowledge of textiles to in a different setting.
My name's Emily Camera. I'm a mechanical engineering major and I'm going to be a senior. I like this project because it's engineering in a field that's not typically where you see engineers. It's very important to have different parts of engineering working together.
Being able to bounce ideas off of each other. She had more knowledge of like the mechanics of everything. Me, I'm more of a textile, like what's this material made of, how is it structured. So being able to work with someone and just kind of combine our different backgrounds together to work on a project has definitely been beneficial.
My name is Helen Trejo and I'm currently a PhD student in fiber science and apparel design. I became interested in the project because it's a collaborative effort to reduce the amount of post-consumer clothing and textiles from the Green Eileen Take-Back program. We're getting clothes that they consider to be unsellable, and we're thinking about the second, third, fourth life of the clothing by reclaiming and upcycling the materials. I deconstructed several Green Eileen knit and woven pants and created a line of scarves. I ended up adding embellishments to the scarves with the existing Green Eileen yarns, so they have elements of crochet and knitwear in them. And I documented how much fabric I used. With the extra fabrics left over, I also created accessories such as hair ties and also earrings. The most interesting part of working on this project is that it's a group effort, and we've also had the opportunity to interact with the Green Eileen upcycling team in Irvington, so it's been great to see their work and also learn from them.
My name is Kelsey Doty, and I'm a first-year PhD student in apparel design here at Cornell University. So for this Green Eileen project, I really worked on designing textiles for both apparel design and for interiors. My process was to really look at the textiles and figure out a way to use the big pieces right on down to every small little bit and scrap to give it added value and continued use. I could use a lot of the skills I've been developing over the past 10 years, including things like hand spinning and knitting and weaving and natural dyeing, and just being able to bring in all those things that I love. So the most interesting thing I learned from using these really amazing textiles is that every little bit counts, and that you can really salvage every little scrap you're given to make something beautiful and interesting.
My name is Micah Bachleg. My major is Sustainable Design Studies within the Department of Design and Environmental Analysis. I'm using fiberized material to make home good products, three-dimensional products that maybe aren't in the realm of textiles or apparel. And so what that has been entailing is, well, right now we're getting into actually making 3D composites from fiberized material and then this soy resin solution that Viana and Professor Natravalli sort of came to within their own lab. And so that's been really compelling, I think. So my process is really, just traditional sketching, some 3D modeling, and just now we've started making the actual composites with the soy resins, and it's starting to get really exciting now because we get to troubleshoot, and use molds to see how it comes out and see how this soy resin is reacting with the fiber. This whole process has been, an experience has been really informative to me, I think. One, coming not from a textile or apparel background and sort of coming into this world of trying to find uses for all this material has been really, really interesting to me. And I think that's one point. I think another point is, I think the whole group and Tasha always comes back to, at the end of the day, how much are we diverting from the waste streams? And so that has been really constructive and informative to me, always to come back to sort of one of the bottom lines being like, how much are we diverting?
My name is Tasha Canty and I'm a fiber science major.
I'm working on the hydroponics process right now, and so far it's just been a lot of fiberizing and fabrics and identifying the structure. Pretty much everything's been interesting. It's been tying into what I'm learning right now and what I learned my last semester in my fiber science classes. Like reading through the biodegradability studies, I could tie it into one of my lectures from 1350, so it's pretty cool. It's like I'm studying while I'm doing this.
My name is Nidia. I'm interested in sustainability, water quality, and exploring new product categories for textile. I contributed to the hydroponics project, and I specifically looked at the properties of green lean fabrics. So we initially started with 28 fabrics, and we studied the moisture wicking and dye release properties. And based on our results, we took out fabrics that had slow moisture uptake. And as a chemical hazard precaution, we took out the fabrics that we observed released their dyes. We narrowed it down to 16 fabrics, and the ones we're using are cotton, linen, tensile, rayon, wool, and silk. And so we added those as a substrate to grow basil plants. We have the fabrics as cut fabric samples and in their unraveled form. So we're excited to see the results in April.
My name is Rain, and I'm a physics major. Last semester, I worked with the Fiberizer V1, and I did a lot of fiberizing, like turning fabric into fibers. This semester, I've done more work building the Fiberizer V2, some design work, mostly a lot of assembly. Coming from like a math and science background, I didn't understand like how complicated fiber could actually be. So it was really interesting seeing the different, aspects of fiber, the different, ways it can be knit, it can be woven, the forces that act on the fibers has been really interesting and something I didn't expect.
I worked on the Fiberizer, so I'm the only mechanical engineer on the Fiberizer team. I spent the fall semester and most of the summer designing version 2, which was largely based off of version 1, and currently in assembly right now. I think the best part about this project was applying everything that I've learned in my classes to a real-life application. Working with people who aren't engineers was also a great experience. I learned different ways of thinking, and that there's different ways of looking at this machine rather than just functionality. You want to be able to make it look nice and have it be functional for the user, not just in terms of efficiently shredding this material down to its fibers. You want to be easily able to interact with the user, and just some things that I didn't really think about when you go through the course structure of engineering.
My name is Skylar Duffy, and I'm an MS in Sustainable Design. Building the Fiberizer V2, we were able to take the plans from Fiberizer V1 and kind of just take a good idea and run with it. So just with a few modifications, a few design changes, just a little bit of refinement, we were able to add a modular blade cartridge that enables different treatments of different materials. So let's say you wanted to fiberize a knit wool versus a woven cotton. Using different blade cartridges, you could get different effects. It has been absolutely encouraging to work with industry on this project. to reconsider sustainability instead of as an added cost that erodes the bottom line, but as processes that can potentially add value and maybe even be taken one step further to have a social impact is absolutely amazing and very important as we move forward into the 21st century.